Welcome to Knowledge Chat channel. In this video, we will be discussing about source transformation. It's a case study. As you all aware of what is a source transformation, I think in previous videos we have I've given a slight introduction of what is a source transformation. But in this video, I will be just explaining what is a source transformation, what are the different types of source transformation, and in that a specific type called as current to voltage source. That particular case we will be discussing in detail. So let's move on to the topic. So basically the energy sources is classified into two types. One is the voltage source, the other one is the current source. So voltage source is nothing but the voltage always remains constant irrespective of changes in the load. If it is a current source, it means that the current remains constant irrespective of changes in the load. Then which parameter is going to vary? For example, if it is a voltage source, the output current will be varying, whereas the input voltage will remain always constant. According to the magnitude of load, the output current will be varying. So if you are using a current source type, then it means that the output voltage will be varying, whereas the input current will always remains constant. Okay, and the output voltage will change according to the magnitude of the load which has been connected. So this is how this energy sources will behave, and these are the two different classifications. One is called as the voltage source, the other one is called as the current source. So source transformation circuits, voltage to current source and current to voltage source. So case study problems we will be discussing. Okay, these are the things which we are going to discuss in further in detail. So here you can see that for example, if I have a voltage source along with the resistance Rs in series. So if you want to convert that to a current source, then the magnitude of current source will be equal to, that is I equal to V by Rs. V divided by Rs is nothing but I. This Rs has to be put in parallel with respect to the current source. For example, if you are having a positive voltage source, the arrow mark will be in upper direction. If you are having a negative voltage source, the arrow mark will be in the downward direction. That's all. It will be in the opposite direction. Okay. So this is how the voltage to current source transformation takes place. Then how this current to voltage source transformation takes place. So here you can see that I have taken two different types of current source. One is the positive current source, the other one is the negative current source. So positive current source is something which has been indicated with the upper arrow, whereas the negative current source is indicated by the arrow with the down arrow. So as you all know that any current source will be having a parallel resistance, whereas voltage source will be having a series resistance. So for example, in the first case, a current source with the upper arrow and the resistance is connected in parallel with it. So how to find the voltage source if I want to convert this current source to voltage source? Because in solving some circuits, you will be facing some circumstances where you want to convert the voltage source to current source or current source to voltage source or something like that. Okay, so you should be very familiar of how to convert. Okay, that's very important. So V equal to IR. So it's a simple Ohm's law. So I is there, R is also known. So I into R is nothing but V. So this is the voltage source. Since the arrow mark is facing upward, it's a positive voltage source. And here in this case, you can see that the current is in downward direction. So you can see that the voltage is negative. Okay, the upper plate is negative, the lower plate is positive. So it is negative voltage. So always the resistance will be connected in series in case of the voltage source. Always the resistance will be connected in parallel in case of the current source. So this is what you want to remember. Okay. So now, as I already told that we will be solving some case study. Okay. So here I have a circuit with 5 amps of current source and 8 ohms has been connected in parallel with it. I want to convert this current source to a voltage source. So how to do it? So you can see that as you all know, V equal to IR is the basic formula. So I want to find what is V. So V is nothing but 5 into 8, which is nothing but 40 volt. Instead of putting this resistance in parallel, it has to be connected in series, which is something with 5 ohms. So this is the equivalent voltage source of the given current source. It's very simple to find. Okay. So now in this related with this and we have some discussions in the classroom as well. Okay, related with this, and let's go into that particular discussion. I just want to tell you how we discuss in our class.
In this video, we will be discussing about what are the pros and cons of different types of HCD architectures. So, as you all know, there are three types of architecture. One is the series HCD, parallel HCD, and series parallel HCD. And now our students are going to present what are the pros and cons and how it operates. And let me go to the dictation first, and then you just explain what are the different. Okay, we discuss about the different types of architecture. Can you tell me how the series HCD operates and what are the advantages?
Series HCD motor provides proportional power in IC acts as a primary mover to rotate generator to charge the battery.
What are the advantages actually?
It was simple in design, similar to EV.
So now we move on to the parallel HCD. So parallel HCD, start with explaining about how it operates. So both IC engine and electric motor will combine this power and will go to the gears. That's what the parallel electric motor rating will be less. Whereas IC engine rating is, because in this case electric motor is just acting as parallel to the IC engine. Here IC engine is going to. And now Mr. John, can you please tell me what are the drawbacks of parallel HCD and why we are going to the series parallel? First to explain what are the drawbacks of parallel HCD. Complex circuit. Series parallel architecture, can you explain what are the different components in series parallel architecture? So in series parallel architecture, we have a component called as power splitter. The one component called as bidirectional. Power splitter is going to 50, whereas bidirectional inverter is going to convert the power in both directions for charging the battery as well. So that's why it's possible. So by concluding, we can finally conclude like series HCD is good for city driving, whereas parallel HCD is suitable for highway driving, whereas series parallel HCD is suitable for both city driving and highway driving. But series parallel HCD is very costly compared to series and parallel. So based on our reputation, we choose to see the customer. Thank you.